Hey guys, Mr. Midas, it just came from the bottom here up to the top. Hey, in this video today we are looking at differentiating trigonometric functions. So I might cut this into two parts. We'll see how long it takes me to get through everything. Here we go, guys. So, God, my hair is standing up on end. All right, so differentiating trig functions. So what we're going to do is let's first take a look at sine x. So here's the graph of sine, and if I think about the slopes of the sine function at each of these places. So the slope right here is like that. And then the slope at negative 3 pi over 2. And then like this. So we're just going to make these little slope, like if we're making a slope field here for a sine. All right, so what do we got here? We've got a slope here of 1. So the derivative, we're going to draw the derivative graph. Okay. So the slope is 1, so I'm going to go up to 1. The slope is 0, so I'm going to go to 0. The slope is negative 1, so I'm going to go to negative 1. Slope is 0, and then slope is 1. And notice it's going to be doing the same thing on this side. Positive 1. So what does that look like? All right, well, we're going to go ahead and, man, if I can draw here, zoom in here, draw it a little better. Just I can't see where my hand's going. There we go. So what does that look like? That looks like cosine. And guess what? It is cosine. The derivative of sine is cosine. All right? So the derivative of sine is cosine. That's kind of neat. All right, so these because they're periodic like that, they're essentially going to give us another periodic function. So here's a table, and you should really, these are just chain rule. So this stuff on this side, oops, not on this side. The second part right here with the u prime, this is just the chain rule version of it. Okay, the ones that you really need to memorize are going to be anything here, right? The derivative of cosine is negative sine. The derivative of cotangent is negative cosecant squared. The derivative of cosecant is negative. You know what? Anytime you see a co, you're going to have a negative derivative. All right? The other ones have positive derivatives. Anyway, you're going to have to memorize these, guys. There's no way around it. All right? Let's take a look at a few here. So let's differentiate. And again, we're going to be doing is have your, if you wrote this down and you paused me and, oh, did you think I was paused? I'm just kidding. If you paused me here and you wrote these down, then have them next to you because I'll just be doing the problems and you'll have to see what we're kind of looking at, okay? So let's go and do some derivatives. The derivative of cosine of 3x squared. All right, so the derivative, this has something inside our angle, right? Inside our angle, cosine theta is 3x squared. So if we have something inside our angle, then we're using the chain rule. So the derivative of cosine is negative sine 3x squared times the derivative of the inside, which is 6x. All right, so we can rewrite that if we'd like to, negative 6x sine of 3x squared. And the only reason I'd like to rewrite that is so that way the 6x isn't multiplied by the angle. It's actually multiplied by the entire sine. There we go. That's it. That's the derivative of that one. All right, let's take a look at another one. Number 2. Y equals tangent to the fourth 5x. So what we're going to do for this one is we're going to make sure that I'm just going to rewrite this guy a little bit here. Tangent 5x, and I'm going to raise that to the fourth power. That's really what it looks like. Okay? All right, so the derivative, y prime, is going to be 4. We're going to bring this down. 4, using the power rule, 5x to the third, subtract 1, times the derivative of the inside. So the derivative of the inside is tangent, so we got to do the derivative of tangent. The derivative of tangent is secant squared, 5x, times the derivative of the inside of that. The inside of that is 5x, so the derivative of that is 5. All right, so we got to keep going until we get all of the insides. And then we're going to simplify this to 20. Just the 5 in the thing. And then there's not really much we can do here. Tangent cube of 5x times secant squared 5x. You know, that's pretty much all we could do. But you can leave it like this if you wanted to. No reason. No need to simplify unless you're being asked to simplify. Okay, cosecant. The derivative of cosecant is negative cosecant of whatever's inside times cotangent of whatever's inside. Times the inside, right? The inside's t over 2, so we got to use a chain rule, times 1/2. Okay? There you go. All right, or if you want to write it like this, you can write it like this. But again, this is just applying derivative rules. Okay, this one we have e to the negative 2x times cotangent. So we're going to have to do the product rule and the chain rule. Woohoo! Two rules in one. All right, g prime. So the derivative of, I'm going to go the derivative of the first, which is e to the negative 2x times negative 2, because I got to do the derivative of the power by the chain rule, times the second, plus the first, times the derivative of the second. The derivative cotangent is negative cosecant squared. Right? Don't forget, anytime you have a co, you're gonna make it. The derivative is gonna be a negative. All right, and that looks good. I think I'll just leave it like that. All right. If you want to simplify it, some of you are going like, I need to simplify. Negative e to the negative 2x cotangent x plus minus e to the negative 2x times cosecant x squared. Cosecant squared x. All right, that's fine too. Okay, so there are a couple examples. Let's take a look at some more. Without a calculator, find the slope of the graph of y equals 3 cosine negative x, where x is pi over 2. So whenever we're looking for the slope, we're trying to find we need to find the derivative. So let's do the derivative right here. Y prime is going to be, the derivative of cosine is negative sine times the derivative of the inside, negative 1. So I'm going to get 3 sine of x is going to be my y prime. So for A, y prime of pi over 2 is going to be 3 times the sine of pi over 2. And because I know my unit circle so well, I know that sine of pi over 2 is going to, I forgot my negative. What was I doing? There's still a negative there. Sine of negative pi over 2. And I know my unit circle so well. I still know my circle so well, even though I forgot that negative there. And that's going to be negative 1. Okay, negative pi over 2 is right here. Right there. And that's going to be, I know it so well, guys. I know it. I do. 0, negative 1. Negative 3 is going to be your answer for that. Okay, so let's do the next one here. So we have, again, so what we're doing is we're doing y prime of negative pi over 3. And that's going to be 3 times the sine of negative pi over 3, which is 3 sine of pi over 3. And because I know my unit circle so well, it's going to be square root of 3 over 2. I don't know why I did that crazy sound, but hey. Singing math. Okay, so that's that one. Example number 6. Okay. Oh, look at that. Why do you suppose I have a limit in a video in which I'm doing derivatives of trig functions? Riddle me this, Batman. Why would I have such a thing? Well, it's likely because I'm going to use L'Hopital's rule. The tangent of 0, okay, I put 1 in here. 1 minus 1 is tangent of 0, which is going to be 0. ln of 1 is 0. 0 over 0. L'Hopital's rule. Let's L'Hopital this guy. So limit as x approaches 1. The derivative of tangent is secant squared. The derivative ln is 1 over x. Now let's plug in 1. And we're going to get secant squared of 0 over 1. Secant squared 0. Secant, again, secant is 1. 1 over cosine. Cosine of 0 is 1. So we're going to get 1 over 1, which is just 1. Boom. See that? That was nice. L'Hopital's rule. All right. Actually, I only have a couple more examples. I think I can fit it in this video if you're okay with that. Actually, I have one more example. Find the x values of the relative extrema for each function. So we can do anything that we did with derivatives before. We're going to just now apply those same ideas, those same concepts, only now we're going to apply those with trig functions because we are going to be using the derivative of trig functions. So let's first take the derivative, and we're going to derive sine as cosine. The derivative of cosine is negative sine. So we're going to have cosine x plus sine x. Find the x values of the relative extrema. So I need to set this equal to 0 to find my critical values. So I'm going to have cosine x equals negative sine x, right? Because I subtract sine to both sides. And what we're looking at is for what x value, for what angle are the cosine and sine going to be the same but opposites? Well, that's only going to happen at 3 pi over 4, because we're going to have negative square root of 2 over 2, positive square root of 2 over 2, and it's also going to happen in the fourth quadrant, which is going to be 7 pi over 4. Okay, so just real quick, that's right here and right here. Okay, because this is going to be root 2 over 2, root 2 over 2, and this is negative. This is root 2 over 2, and then negative root 2 over 2, so they're opposites. All right, so, okay, so then we're going to draw our little table here of f prime and see if we have any increasing or decreasing. So we got zeros here. Let's check a value in between. What's in between that? So let's try pi. Pi is in between that, right? There's pi. So if we put pi in here, cosine of pi is going to be, cosine of pi is 1 comma 0. Cosine is 1. Sine of pi is 0. That's going to give me a positive. So these are going to be positive values. Oh, negative 1. Sorry, negative 1. It's going to give me negative values. It's going to be negative 1 plus 0. Values that are less than 3 pi over 4, that's like over here. At pi over 4, that's going to give me a positive. And then bigger than 7 pi over 4, which is going to be over here again, which is going to give me another positive. So that's going to give me f. This is f prime. F is going to increase, decrease, and increase. So I have a relative max there and a relative min there. So I have to figure out what those values are. So my relative, oh, it says x values. Good. So relative max at x equals 3 pi over 4. And relative min at x equals 7 pi over 4. Bam! That's it. That's all there is to it, right? So there we go. I've given you some examples of using derivatives for trig functions. Some examples of stuff that we did before, L'Hopital's rule, slope of a line, relative extrema. What you're really going to have to do is learn those and memorize those. Catch you later, guys. Bye.